morning friends, welcome back to my YouTube channel. So today I will tell you about the simulation of buck boost converter using the MATLAB. So this is the circuit diagram of typical buck boost converter. This is switch, this is voltage, DC source, it is 100 volt, inductor 0.1 millihenry, diode, and this is capacitor 147 microfarad, and resistive load is connected of 100 ohm. We will observe the waveform across the load and this inductor waveform also, or this current waveform IR. You know what is the formula for this output voltage? Minus T by 1 minus T VDC. VDC is the input voltage, D is the duty cycle, taking here duty cycle 40%, and F is the switching frequency pulse which we are providing to this MOSFET switch. Here switching frequency is 20 kilohertz. So let's see the simulation. This is the circuit diagram which I made here in the MATLAB. So from where I took all these components. So this is pulse generator, see its setting. Pulse generator amplitude of the pulse 1, period is 1 by 20 kilohertz, it is in second. Pulse width 40%, phase delay 0. This is MOSFET switch, इसमें आपको कोई changes नहीं करने, as it is रखना है. This is DC voltage source 12 volt. This is inductor 0.1 millihenry. This is diode, capacitor 147 microfarad. This is resistive load of 100. This is the voltage measurement, mean value. Just I am taking mean of this voltage, or directly this is the current measurement. This is mux. Here this is the scope. You can see two waveform at a time. This is power guy with the help of this block. Here you have to change it into discrete, and 5 e to the power minus 6 is the sample time. Now you can run this model, but before running this model I want to tell you from where I took all these components. So this is library browser. Open this library browser. So here you will see there is one simscape, this one. Here electrical, then specialized power system, then here fundamental blocks are there, elements. From here you can take this series RLC branch and you can replace it into resistor, capacitor or inductor. Electrical sources, from here I took this DC voltage source in the model. Similarly you can take power electronics component. From here I took this MOSFET or IGBT. This is MOSFET which I took, and here diode is there. You can take this diode, or you can search the component by name. Here you can search, for example, display. So here you will get scope, and this is the display which I took to display the number. Similarly you can search any component. Now run the model. This is the run. I am running here for 10 seconds. See, model is running. So you can observe the waveform of voltage and current across the load. This is the current waveform, and this yellow one is the voltage wave. It gives minus 23 volt or 22.9 volt. If you will change the resistance value of 150 ohm, then you can see there will be change in the current and the voltage. So now voltage is 26.06. So here, as you will change the load, your load voltage will change. That's why we use this closed loop of this buck boost converter, not in oppose. If there is load variation, then there will be change in the output voltage. For a DC application you have to fix this output voltage. You need constant DC output voltage. To fulfill this constant output voltage, you have to do its closed loop control of buck boost converter. I will make another video based on this topic. Thank you for watching.